Hi, everyone. Welcome to our talk about usability and security of TPM library APIs. I'm Siddharth from Nokia Bell Labs, and this work is done jointly with my colleague Gabriela Limonta from Nokia Bell Labs and Janne Lindqvist from Aalto University, Finland. So before we get started, I would like to introduce TPM, although I'm sure that many of you know what it is. So a Trusted Platform Module, or TPM, is a tamper-proof cryptographic chip with a unique identity, and it can be used for secure storage and security operations. TPM is used in a wide range of security applications, and the most common use for TPM is secure booting mechanism as seen in UEFI boot verification and Chromebooks. TPMs are used in BitLocker and Lux description encryption. They are used for trusted remote attestation for the cloud, edge, and IoT devices. Recently, TPMs are also recommended to be used with network function virtualization to enhance the security of servers. I think there is a delay in my slides, but if I'm going too fast, somebody can just flag that. So TPM is an old and widely used technology. However, it's not a go-to choice for software developers. So in our study, we wanted to understand why. We speculate several reasons. So one reason could be that both TPM concepts and security are complicated, so developers do not want to overcomplicate them by combining. Another reason could be that developers do not fully understand the potential and use cases of TPM. It could also be because TPM lacks a supporting ecosystem for software developers, or it could be all the above reasons. So Trusted Computing Group, or TCG, defines APIs as standard specifications. They define low-level APIs for implementing the TPM hardware. They also define high-level APIs for the software applications to communicate with the TPM. So in our study, we focused on the high-level APIs that are implemented as software libraries. There are 5 major implementations of the standardized high-level APIs, and the study platform which we built supports all of them. However, the results discussed in this paper are based on the observations about the TPM2 tools library, which is the most widely used library. So the goal of our study was to review the API implementation together with the developers to understand the usability and security pitfalls. Based on that, we wanted to provide concrete design guidelines for making the APIs more usable and secure. So from a research point of view, what we find interesting about TPM is the combination of its cryptographic and non-cryptographic security features. So TPM can be used for the usual cryptographic operations such as key generation, encryption, signing, hashing. However, TPM also offers various other non-cryptographic features. So firstly, it offers secure storage in its non-volatile RAM and special registers called as platform configuration registers. TPMs can also store sensitive data as sealed blobs. Secondly, TPM offers rich access control restrictions and policies that can be applied to cryptographic keys and TPM's internal and external states. Finally, TPM's unique identity and coding mechanism to capture its state of its host can be used for remote attestation. So now that I have introduced TPM and its features, let me provide a high-level overview of our study. So we started by creating a participant pool of the TPM developers who we invited for a preliminary survey. This survey helped filter out participants and identify common use cases of TPM that we used to create tasks in our study. Meanwhile, we independently analyzed the TPM library ecosystem and conducted a literature survey, which helped us to define the criteria for the task and prepare questionnaires. We built an online study environment using open source components and presented the tasks and questionnaires. We also conducted cognitive interviews with some of our participants. We qualitatively analyzed the data gathered from the study environment and interview transcripts. We targeted TPM developers with security background such that we can design tasks that are close to real life scenarios. 36 out of 48 participants in our preliminary survey expressed interest in participating in the actual study. 13 participants completed the study, and we interviewed 9 of them. Our results are from these 9 participants who completed the entire protocol. The main limitation of our study is that we have a small number of participants and all of them used TPM2 tools library. However, in our paper, we argue that our results are generalizable. Um, so we designed 4 tasks that combined cryptographic and non-cryptographic features of the TPM. So the first task was encryption, where half of the participants got symmetric and the rest got asymmetric encryption. Storing measurements, securing secrets, and remote attestation tasks were common to all participants. Our study also contained questionnaire to collect the perceptions and opinions of our participants. So we collected basic demographics at the beginning of the study, and then after each task, we asked about familiarity and complexity perception of the task. Also, we collected participants' perceptions about their code's security and correctness. At the end, we also asked about the usual choice of reference materials and reasons for looking for information outside the library documentation. We conducted the analysis in 2 phases. So in phase 1, we analyzed the code snippets executed in the study platform and questionnaire responses. The code snippet and responses were used as for the interview as prompts and probes. In the phase 2, we conducted a thematic analysis of the interview scripts. We also have 2 types of results. So first, we have the themes of usability and security pitfalls. Second, the common coding patterns of developers' habits and mistakes. So we identified 18 themes from the thematic analysis. The first set of themes were about the API library software. So we found usability and security issues due to improper naming conventions, output formats, and error handling. In the second set of themes, we identified several shortcomings in the library documentation. And finally, we discovered themes related to mental models and trust factors formed from prior experience of our participants. We also uncovered common coding patterns that affected the security of the code. Mainly, the participants heavily relied on the defaults. Also, they were careless while specifying the cryptographic and TPM specific attributes and do not consider the threat models. Due to time constraints, we present a simple example. The result is picked from the library themes category about error handling, which lacked pointers on how to resolve the error. So in the encryption task, a participant had not used the initialization vector. And as you can see, the warning message just says, using weak IV, try specifying an IV. The participants find this to be unhelpful because the error message does not assist in any way in resolving the error. Also, the documentation provides a bad example by giving a code snippet for the encryption command that actually does not use the IV parameter. So our study highlights that TPM APIs that we study, and most likely all other APIs, do not follow the secure API development guidelines, for example, suggested by Greens and Smiths. So we provide 2 types of immediate recommendations based on our findings. So for the library documentation, we found that experienced developer struggle to use TPM security offerings, whereas less experienced ones have many misconceptions about the TPMs, what TPMs can and cannot do. So to avoid this, we recommend the documentation to include information about TPM concepts. And we also found that all participants found the examples in the documentation not very helpful. Therefore, our recommendation is to provide secure code snippets for common use cases of TPM instead of hello world examples. And we found that every participant seemed to have struggled with getting started with TPM despite their prior coding or security experience. So we recommend that the documentation should somehow include TPM for dummies to cover how to start from scratch and walk through examples. And also, we recommend the documentation to include guidelines for picking security attributes. Finally, we found several incoherent aspects in naming conventions and between software versions. So we recommend to fix them all. For the library software, we recommend that the error messages and output should be developer friendly, and it has to be specific and concrete. In particular, these messages should convey a success message, and it should convey the error-free execution of the command and also give feedback on what the command has achieved. And also, it should alert about the interpretation of the result or immediate steps that has to be taken by the developer. And also, it should include descriptive meta information. We recommend the library software to promote and highlight the advantages of abstraction functions whenever available. And we also suggest that the library should create new abstraction functions around common use cases of TPM. As said earlier, the developers rely on defaults. So the libraries must default to the most secure option available and discourage or discontinue legacy and insecure ones. We now conclude this talk with a summary of our contributions and results. So first, we built an open source platform for TPM related tasks that works right out of a browser, and it can be used for future studies. Second, we presented qualitative results about the TPM tools library. We found that the APIs and supporting materials are not developer friendly. We also provided concrete recommendations to immediately address the issues that we identified. Finally, we found that many usability and security pitfalls in software stem from standard specifications they follow. So HCI experts should be involved in the design of technical specifications. With that, we advocate for what we call as usability by design approach while designing APIs. Thank you for your attention. For more details, please read our SOUP paper or contact us. And also our GitHub repository for the TPM study platform is also at your disposal. So feel free to tinker with it. Thank you.
Thank you. I love these kinds of very specialized security usability topics. We've got a question on Slack from Anna Marie. Hello, you mentioned your results being generalizable despite the small sample, but I might have missed this. But could you give a few more details on why you consider it to be so?
So first thing is we see this pattern. TPM2 tools is actually a quite widely used library. And all the other libraries have some sort of copy the same cell, and they all stem from same TPM specifications. So it's most likely that they follow the same pattern or they have the exact same pattern. So the problems which you identified are in the specifications, which means that every API that has followed the specification might also have the same problem.
Thank you.
So in fact, like when we built the library, we supported all of them, but this seems to be a very favorite choice of all developers. So although they knew multiple libraries, they just picked TPM2 tools for some reason.
Great, thank you. We have an in-room question.
Yeah, I appreciated the recommendations that you gave that were super specific. For the library docs in particular, you mentioned including the background info about TPM concepts and then also including guidelines for picking security attributes. I'm curious if you found that it was also important to provide background info about those security attributes or privacy or security concerns that a developer should be thinking about, similar to the TPM concepts.
Yeah, I think so. So one of the main problem we found was unless and until the threat model is given or somehow it is conveyed through examples, even if you provide the concrete examples or concrete guidelines, they wouldn't pick it. So with this background information, we feel that TPM or any topic which is kind of complicated, it should somehow educate the developers about what to look for, what kind of attacks are there, or how they can defend through code.
Cool.
So mainly that is helpful if they provide, like, instead of hello world example, if they create some sort of real world walkthrough examples, that'll be helpful. That's our finding.
Thank you.
All right.
Time for one more. James, do you want to go for it?
Yeah, sure.
Great, thank you.
Hi. So in your recommendations, you mentioned that you'd provide codes. You recommended providing code snippets on examples of what to do, and I was wondering if you thought there might be any value in providing examples of like what not to do, or maybe common pitfalls, and how maybe you could couple that with different threat models to show how improper use may still leave you vulnerable, or may still leave kind of holes in security that you think you might be patching when you're not.
Sorry, can you repeat the question?
So I was wondering if so in addition to providing code snippets of what to do, I was wondering if you think there's any value in providing code snippets that show common pitfalls or things that you should not do.
Definitely. I think like one of the reasons why we kind of also collected what are the common mistakes or what the developers have done is to somehow create this list of everything what not to do, and somehow also include them. And just like how FAQs, security and privacy FAQs could be the potential venue for that, listing and educating them.